would say that one of the things that many students have trouble with in chemistry is conversions. And so this lesson might be something you have to look at more than once, and it might also be something that you really need to practice, problems outside of what I show here. And remember, you have homework problems as well as examples in the book. So if you find yourself struggling with conversions, don't be discouraged. This is something that people have a hard time with. So when we talk about a conversion, what we're talking about is changing one unit into another, right? So we're just going to take one unit and convert it into another. So we may start with grams and then change that number into kilograms. Now there's a method, and it's called different things. I've heard it called factor label method, the conversion factor method. There's different things that we call it, but what we're going to use is something called conversion factors. So here, this is what I'm saying. We're going to use conversion factors. So the first thing you might ask yourself is, well, how do I get a conversion factor? Like, what is a conversion factor? How will I know when I see it? You know, how do I come about a conversion factor? So that's where, to figure out how to do a conversion factors come from equalities. So an equality is when you have any two units that are equal to each other. So when we were talking about metric units, we said that 1 centimeter equals 0.01 meters. That's an equality because that tells us how many centimeters are equal to a meter. Or we said that there are 12 inches in 1 foot. That is also an equality. Or I could even look on my aspirin or my medication tablet, and it could tell me that I have 240 milligrams of the active ingredient in 1 tablet. Now, all of these things that I've just written are equalities. Now, there'll be different places we can get our equalities, and it's from equalities that we're going to get our conversion factors. Some of them, like the metric ones here, the metric ones, I've given you a list of 5 that you need to memorize, so you would have to know that. Other ones, like the English to English or English to metric, you'll be able to find on a table. On slide 2, here's a table on slide 2. This is from your textbook, and you see that it has some equalities on it. They call them equivalents. So these are equalities. So these are ones that I would give you something, either this table, or usually I just give you a few that you're going to need to know. Okay, so these are all equalities, and these on this table, I don't think you'd have to memorize. I don't see any metric to metric. Nope, none of them on this table would you have to memorize. Okay, so these would all be given. So some of them would be given. So this guy is one of the ones that I've asked you to memorize. So that may be how you find an equality, is because you've learned it. This one you might have in a table, so you would be given. And then sometimes it will just be given to you in the problem. So they'll tell you that there's 2 things that are equal to each other, and you'll have to use that to figure out your conversion factor. Okay, so that's what equalities are, and equalities are how we're going to create our conversion factors. And I'm going to do it I'm going to make conversion factors for the 3 that I have up here. There's some other ones in the notes that I'll point out. Okay, so coming back over here, it says, coming over here, you'll take an equality, which is any 2 units that are equal, and write them as a ratio. And a ratio simply means that you write one on top of the other. So let's go up to this first one right here. So those two things are equal. So the conversion factor, I could write it as a ratio. I could write 1 centimeter over 0.01 meters. Or, depending on what my problem is, and I won't know till I have a problem, I could put the 0.01 meters on the top and the 1 centimeter on the bottom. And that's a conversion factor. So when I say I need a conversion factor, I just use the equality that I had memorized. Now let's look at the next one. Hopefully you'll start getting the idea. So this second one. Okay, so I looked up on a table to know the relationship between inches and feet. And so to write a conversion factor, I could either write the 12 inches in the numerator on top and the 1 foot on the bottom. Or, depending on the problem, I might want to write the 1 foot on the top and the 12 inches on the bottom. Now, all of these three equalities and subsequent conversion factors, I've kind of just pulled randomly from my mind. But if we were doing this in a problem, it would be specific. Like you would know which ones you were supposed to use. And we're going to try... we're going to do specific problems. In this exercise, I'm just trying to get you to understand an equality is when two things are equal, and then if we know two things are equal, we can write one on top of the other. That's a conversion factor, and we can use that to solve our conversion problems. Finally, the ones that could just be given in your problem, you're just reading the problem and you see it, like this last one, we would write its conversion factor the same way. We could put the 240 milligrams on the top over the 1 tablet. Or, again, depending on what we're given, and we'll see why that matters, we could put the 1 tablet on the top and the 240 milligrams on the bottom. Now, I have given a few other conversion factor, a few other examples. Oh, I see I used 2 of the same. I only used 1 that was different, but I had some over here in the notes. So here, when we're thinking about conversion factors, the conversion factor relates to units. It will have 1 unit on the top and 1 unit on the bottom. See, on here we have centimeters and meters, 2 units. It's relating them, inches and feet. And on this one, milligrams, and although you might not think of it as a unit, we can use it as a unit, tablets. Now here's how we're going to use it. This is the important part. The conversion factor must cancel out an unwanted unit. So that's what we're going to investigate. I'm going to have you do a problem where you can try to do conversion factors first, but after that, we're going to investigate this idea. So hold this idea in your head. The conversion factor must cancel out the unwanted unit. So again, I have this page in our notes because we're going to have to refer to this on some of our problems. Okay. So you can pause it here if you want to and try to write the conversion factors for these relationships. And then right now I'm going to start doing the answers. But if you want to pause and try it yourself to see if you're understanding, which I think is a good idea, then go ahead and pause it now. Okay. So to get the answer, so milligrams to grams. So I know 1,000 milligrams equals 1 gram. That's the equality. So the conversion factor would be 1,000 milligrams over 1 gram, or 1 gram over 1,000 milligrams. Now, on this example, you might have also said 1 milligram equals 0.001 grams. That's an equivalent equality. So if you did that, it would look like this. And either one of these ways, if you wrote it either one of these ways, they would get you the right answer. Whoops, sorry, I touched a button. I'm getting too close to the edge. Okay, I didn't mean to do that. All right, minutes and hours. So I know there's 60 minutes in 1 hour. So I could write that's the equality. That's not what the answer. This one's the conversion factors. So here's the answer for this one. Or this. And this one I would write 60 minutes over 1 hour, or 1 hour over 60 minutes. And then finally, letter C, quarts to milliliters. Now this is English quarts to milliliters metric, and I don't know that. So this is one I would have to look on a table. So if we come over here, I'm looking at metric to English. And here we go, right there. There's quarts on one side and milliliters on the other. So it's 946 milliliters equals 1 quart. So I'm going to come up here. 946 milliliters equals 1 quart. Okay, that's the equality. That's not the conversion factor. The conversion factor, I would just take it and I would say 946 milliliters over 1 quart, or 1 quart over 946 milliliters. Sorry, I'm kind of moving all around the page, but this is what I would do in class. So, okay, so that's writing conversion factors for the relationships. So now let's look at question 11. This says, write the possible conversion factors for each of the following statements. So these are statements that tell us things that are equal. So the letter A says there are 325 milligrams of aspirin in 1 tablet. So I know that 325 milligrams equals 1 tablet. That's the equality that the sentence is telling me. So the conversion factor is 325 milligrams over 1 tablet. Or you could write the 1 tablet on the top. 1 tablet over 325 milligrams. Okay. Letter B, 1 kilogram of bananas is equal to $1.25. It costs $1.25. That's telling me two things that are equal. I can get a kilogram of bananas if I pay $1.25. So then the conversion factor would be, you just take a kilogram and it could go over 125, or depending on what I'm solving, you could take the 125 on the top and the 1 kilogram on the bottom. And then finally, letter C says the label on the bottle reads 10 milligrams of furosemide. So the 10 milligrams of the furosemide equals per milliliter. So that's for 1 milliliter. So I could say 10 milligrams is in 1 milliliter of my solution, or 1 milliliter has the 10 milligrams. So you can see, to write a conversion factors, you have to first find 2 things that are equal and then put one of them on the numerator and one of them on the denominator. So now the question may be to you, well, how would I know? Like, how do I know what to write on the top? How do I know what to write on the bottom? I get the idea of equalities and conversion factors. So here's a page that says how to. All right, so let's go through it, and then I have 3 problems for us to try on the next slide. Now, remember, conversion problems don't come easy for a lot of students. So you may have to listen to this more than once. You may have to find another resource to go over it. You may have to ask in class, and you may have to practice. Please don't be afraid to keep practicing. The idea of conversion factors and converting is important in chemistry, and it will help you solve a lot of different problems. It's not just limited to chapter 1. So this is an important concept. Okay, so how to solve problems using conversion factors. Number 1. Identify what is given. Okay, so we're going to find out what is given, and we're going to find out what we're looking for. And a part of that is going to be really paying special attention to the units. Okay, so if I look down here, here's an example. We'll follow with it down here. So it says, here's the problem right here. Convert 130 pounds, which would be, that's what I'm given, to kilograms, and that's what I'm trying to find. So the two units I'm working with, I'm given pounds, and I'm trying to find kilograms. Okay, that's what number 1 says. Then it says, find an equality that contains the unit that you are given so that you can make a conversion factor. Okay, so this is metric to English. So let me go back to this table. We have pounds and kilograms, right? Okay, so right here. Do you see right there? I have pounds, which I was given, and then I have kilograms, which I was looking for. So that's my equality. So if you look down here, oh here, I wrote it down here. The equality is 1 kilogram is 2.20 pounds. And remember, I looked that up on a table. That wasn't something that I had memorized. Okay, so I did this. I did step 2. I figured out what I was given and what I was looking for, and I found a conversion factor that will help me. So step 3 is, how am I going to set up the problem? And you can always do this. So look here. You're going to follow the units and make sure they cancel. I often mention in class, if I had a math problem and it said 3/7 times 7/5, and I wanted to simplify this, I know that if I have the same unit on the bottom and on the top, that those would cancel, right? So if I had 2/4 and I multiplied that by 6/2, the 2 on the top and the 2 on the bottom could cancel. And I know that can reduce, but you get the idea. Well, units work the same way. If I had centimeters on the top and I multiplied it by something that had centimeters on the bottom, those two units would cancel and be gone. So let's see how we set it up. First, we write down what we are given, including the unit. So if you look back up here, I was given 130 pounds, so I write that down. Next, I know I'm going to in conversion problems, you multiply. Next, arrange the conversion factor so the unit in the denominator cancels the given unit. So here was my equality. So I know I could write a conversion factor like this or like this. And so I want to use the conversion factor that will allow what I was given to cancel. So if you see here, if I'm given pounds, I'm going to put the unit of pounds in the denominator so that they will cancel and go away. So I would choose to use this expression of the conversion factor because pounds would be on the bottom, and so my pounds on the top, my pounds on the bottom would cancel. Then once I do that, it's just doing the math. So I'd say 130 times 1 divided by 2.20. And I get to two significant figures, 59, and then I have my new unit left, kilograms, because it didn't cancel. Now you might say, wait, how did you get two significant figures? And if I'm looking at it, this number has two significant figures because there's no decimal. And so I'm going to go, usually with what you're given, that's what you'll go with. So I went with two significant figures. Now sometimes there'll be a problem, and we're going to practice one, that require more than one conversion factor. So I have to have a process of canceling out several units before I get to my answer. Now, it might be a good idea just to go over this problem again. Maybe even go into your textbook and look at a simple conversion, one of the first problems that they introduce you to. But we're going to go ahead and we're going to try 3 conversion problems in this video. Okay, so question 12 is what we're going to start with. Says the daily recommended amount of potassium in the diet is 3,500 milligrams. How many grams of potassium are needed each day. Okay, so remember what I said. You want to identify what's given and identify what you're looking for. So reading the first sentence, I know that I have 3,500 milligrams of potassium. And that's what I'm given. I also always think whatever you're given, that's how you're always going to start these problems. So I can tell you before I even know anything else that my problem's going to start like that. It always will start with what you're given. So I'm given 3,500 milligrams, and I see the new unit they want me to find is grams. So in order to go from milligrams to grams, I have to know the equality. So I know that there's 1,000 milligrams in 1 gram. So to write my equality, one's going to go on the top and one's going to go on the bottom. Now, how will I know which is which? Okay, I'm given milligrams. So I am going to want milligrams on the bottom. Now, the reason is because I want them to cancel. So I'm going to write the 1,000 milligrams on the bottom. That goes from here, and then the 1 gram on the top. Now the milligrams will cancel, and in my calculator it's 3,500, which is what I was given, and it's going to be times, whoops, sorry, I dropped my pen. It's going to be times this 1 right here. So it's 3,500 times the 1. Now in my calculator, we know anything times 1 is the same, so I don't do that. Then we say divided by 1,000. So in my calculator, I would say 3,500 divided by 1,000. And so I would get 3.5. So I get 3.5, and my new unit, since milligrams is canceled, is grams. Now, this first number only has 2 significant figures. We're going to be thinking about significant figures. So my answer in the bottom, I'm going to just take the 3.5. I'll just have my answer with 2 significant figures. So question 12 is an example of what we'd call a one-step problem. It only took one conversion factor. So let's do question 13, and I designed it, I hope I tried to, so that it would have 2. Okay, so let's start over. So it says 1 medium bran muffin contains 4.2 grams of fiber. Okay, that's what I'm given. I have 4.2 grams. How many ounces of fiber, that's what I'm looking for, are obtained by eating 3 bran muffins? Okay, so if I have 3 muffins, I have 3 times 4.2 grams. So I'm eating not just 1. Well, you know what? I'm going to do that at the end. I could do it at the beginning, but I think I want to do it at the end. Okay, sorry. So I have 4.2 grams. So I know that's what I'm given. So my problem's going to start like this. All right, so I can already tell you I need to find something that has grams on the bottom. And I'm going to ounces, okay, which is an English unit. Let's go back and look what I got here. All right. I'm going to erase some of these things so I can look at it better. Ah, I see what I want. Okay, so okay, this isn't I will do this in one step by what we knew. Okay, so here I can tell you 28.3 grams is 1 ounce. 23.8 grams. I thought I had set up a 2-step one. 23.8 grams equals 1 ounce. I guess it's still kind of 2. So that is 20. I'm going to put the 23.8 on the bottom because it's the grams, and I want the grams to cancel. Now, if you want to, right now, you can get an answer. I'm going to show you 2 ways to do this. So you have 4.2 times 1 divided by 23.8. And I get to 2 significant figures 0.18 ounces. On my calculator, I got 0.17647. I'll write it down here so you can check yourself. 6.4, and it kept going. But I rounded it to 2 significant figures. And then remember, I ate 3 bran muffins, so I would have to multiply this number by 3. And I would get 0.5. It says 529, so 0.53 ounces. Now, if you wanted to, you wouldn't have to put the equal in between. You could just do this continuously. Like I could have gone 4.2 grams times 1 ounce over 23.8 grams. You could even think this is in 1 muffin. And then that would cancel. And then you could say times 3 muffins. And have your muffins cancel. So you could, if you wanted to, this is something that's called continuous. And you'll notice in some of the examples I do, I like to do things continuous without getting answers in the middle, but it's not required. That would not be a required step. Part of that will be you practicing to see how you do and what makes most sense to you. Okay, let's try this one more. And I know conversions there's a lot going on here, so just keep being patient with yourself. Keep practicing. So question 14 says an antibiotic dosage of 500 milligrams is ordered. Okay, so I know I have 500 milligrams. The antibiotic is supplied in a liquid form and it has 250 milligrams in 5 milliliters. How many milliliters would be given? Okay, so I know I have a 500 milligram dose. That's what I'm given. And I want to take that 500 milligrams and change it into milliliters. So in this problem, this is one that the question tells me the equality. It tells me that I have 250 milligrams in every 5 milliliters. So that's an equality. And anything that's an equality I can use as a conversion factor. So my question for you in class would be which part of my equality would I put on the bottom? And I hope at this point you're starting to realize that if I'm given milligrams, then the unit I want to put on the bottom is going to be milligrams. And the reason I would do that is so it would cancel. So I would put the 250 milligrams on the bottom and the 5 milliliters on the top, and that will cancel out the milligrams. So then to find my answer, I would say 500 times 5, and then I would divide that by 250. And I get 10 milliliters. So the number of milliliters that would be given are 10 milliliters. If you've ever had to do things in the doctor's office before, you might know that 1 teaspoon is the same as 5 milliliters. So if you had a 10 milliliter dose, that would be 2 teaspoons of the antibiotic. Okay, so again, and I know I've said this multiple times, but conversion problems can be something that are challenging for people. Don't give up. It's really important. Ask questions. Keep practicing. And if you want to see another problem, feel free to come see me or ask me in class, and we will do more problems together. Okay, but keep working on conversions. They're important.